All right, welcome back, Algebra 2. Let's do 2 more examples, okay? The benefit of having these problems be kind of time-consuming is that you won't have such a big practice set as usual. It won't be 10 to 12 problems. It'll be, I'm thinking, I want to envision probably like 5, 6, or 7, because I want you to practice this and make sure you're okay with it, okay? And that way, when we do synthetic division, it'll make a little bit more sense, all right? So let's do a few more long division. Okay, next one. We're going to go ahead and divide x cubed minus x squared plus 4x minus 10. Divide that by x plus 2. Okay, so x plus 2 is our divisor. Okay, we're going to keep labeling it, so let's just, so that way we can be familiar with the terms. And this is our dividend. Okay, so x plus 2 outside of our division symbol. Don't forget to see if you can come up with a fun little name for this symbol. I don't know what it's called, or maybe there is an official name. I don't know. X cubed minus x squared plus 4x minus 10. Okay, let's apply those same techniques, all right? Recall what we did. What did we do? We asked ourselves how many times first term goes into the first term. So how many times is x? Oh, I almost forgot. You should let me know. As if you can tell me, right? Let's check to make sure, do we need any placeholders? Are we missing any terms? It starts with x cubed, so we better see the squared term, the first power term, and the constant term. We do, so we don't have to worry about placeholders. Okay, but always check for the placeholders. That should be your step 1. First step in long division. Wow, I can't spell. First step in long division. Check if you need placeholders. Okay. All right, let's continue now that we've reminded ourselves of that. So how many times does x go into x cubed? What do I need to multiply x by to get x cubed? Well, that is going to be x squared. So since it's x squared, line that up with the squared term in the dividend, and now multiply that back through. So x squared times x plus 2, that's going to equal x cubed plus 2x squared. So we're subtracting that off. All right, minus x cubed plus 2x squared. All right, these are going to cancel. The first ones will always cancel, so you can always be sure of that. Okay, negative x squared minus 2x squared, that's negative 3x squared. Okay, bring down our 4x, so that's plus 4x. If I wanted to, I could actually bring down the negative 10 with it. There's nothing wrong with that. It's just, since there's only 2 terms here, these 2 terms are the ones going to be affected, so we're just going to have to bring down the negative 10 again. But there's nothing wrong with that, okay? Whatever makes more sense to you. I'm going to bring it down just to show you that it doesn't matter, okay? Negative 10. All right, first term with first term, how many times does x go into negative 3x squared? What do I multiply x by to get negative 3x squared? Well, we know it's my computer telling me I'm out of space. I know, you don't have to remind me. We know it's going to be negative 3. And then x to x squared, and multiply that by x. So then negative 3x times x plus 2. That's going to be negative 3x squared minus 6x. Okay, let me look at that really quick just to make sure I did that. Yeah, okay. Try not to make so many mistakes because I know you guys are maybe tired of having to catch them. I apologize. I'm human too, though. So then subtracting off minus 3x squared minus 6x. All right, so notice how that negative 10, nothing's going to happen to it. So that's why you could bring it down or you could just leave it up there. It'll be okay either way. So negative 3x squared minus negative 3x squared, we know what's going to happen there. They're going to cancel out. 4x minus negative 6x, that's going to be 4x plus 6x, so 10x. Bring down our lovely little negative 10. Okay, last one. X, how many times does x go into 10x? That's going to be a nice, beautiful plus 10, positive 10. Okay, so then 10 times x plus 2, that's going to equal 10x plus 20. Okay, so minus 10x plus 20. What do we get? 10x minus 10x, you know what happens there. Negative 10 minus 20, that's negative 30. X cannot go into negative 30 because the degree is smaller. This has a degree of 0. This has a degree of 1. Okay, so let's report our answer. How do we do that? Quotients, so x squared minus 3x plus 10 plus remainder, negative 30, over divisor, x plus 2. Okay, boom. Boom. One more example to kind of drive it home, okay? We're almost there. All right, let's divide. Okay, I know. Thank you for reminding me for the 1000th time. I just bought a new hard drive too. I don't know why it's still yelling at me. Sorry, irrelevant. Divide x cubed plus 6x squared plus 5x minus 12 by x squared plus 7x plus 12. So notice this polynomial here. Do we need to put any placeholders? No, we're good. Okay, let's do it. So divisor, x squared plus 7x plus 12. Beautiful, gorgeous division symbol. X cubed plus 6x squared plus 5x minus 12. And then let's go ahead and get into it, okay? You always, how many times does x squared go into x cubed? First term into first term. What do I multiply x squared by to get x cubed? Well, that would actually just be x, okay? So that's cool. It's x. I line it up with my x. I line it up with my x term and my dividend. So x on the side, x times x squared plus 7x plus 12. You don't have to write this out if you kind of know what it's going to be. But if it helps you to know what it's going to be, then definitely write this work out. X cubed plus 7x squared plus 12x. Okay, so we're subtracting that off. X cubed, oh, let me keep that as orange, just to be consistent. Minus x cubed plus 7x squared plus 12x. Okay, so what do we get when we chop that off? We get, this goes away, like you know. 6x squared minus 7x squared, that's negative x squared. 5x minus 12x, that's negative 7x. Bring down the negative 12. Awesome. How many times? First term to first term. What do I multiply x squared by to get negative x squared? Well, that's just going to be a negative 1. And we line that up with our constant term, so x minus 1. Okay. It's a negative 1. We don't really need to do the work on the side, right? Because it's just going to make it all negative. So negative 1 into all this, that's negative x squared minus 7x minus 12. Oh, that's the same. That's literally identical. So this is all going to cancel itself out because something minus itself is 0. Oh, sweet. Our remainder is 0. Okay, so when we report our answer, it's just the quotient because the remainder is 0. What's our quotient? X minus 1. No remainder. Pretty awesome. Okay, what does that mean though? What does that mean for the problem? Okay, well, when I divide two numbers and there's no remainder, we call them factors, right? If I know that 12 divided by 3 is equal to 4, so that means that 4 and 3 are factors of 12, right? We know that from elementary and middle school. Whenever I can divide a number by something and I get a whole number, I don't get any extra decimal or remainder crap, then I know that the divisor and the quotient are both factors of 12, because then if I flip it, if I do 12 divided by 4, then that's equal to 3, okay? So that applies directly to what we're doing here, okay? That means that x squared, or that means that x squared, let me do it in a different color, x squared plus 7x plus 12, and x minus 1. So my divisor and my quotient are factors of the dividend. So of x cubed plus 6x squared plus 5x minus 12. Awesome. And that really does help us because if you look at this, could you have factored that using any of our factoring techniques? Well, our only factoring technique with 4 terms is factor by grouping. But if you try to do this by factor by grouping, you're going to notice that the two pieces that you have here, we have the junk in between and the junk in the front, but the two factors that you get here are different. They're not going to be the same, okay? And so that'll be an issue because then we can't do factor by grouping. Okay, and then also we haven't dealt with it yet, but sometimes you have 4th degree polynomials that have all the terms. And if we do, one example is x to the 4th plus x cubed plus x squared plus x plus 1. This has 5 terms, and we don't know how to deal with something with 5 terms, okay? So this idea of long division and eventually tomorrow, synthetic division is going to actually help us to factor these big polynomials down when we don't have any factoring techniques that apply, okay? Look forward to it. Okay, I hope this long division stuff makes some sense. And if it doesn't, ask your questions in class. Make sure you're coming in after school or before school or during study labs. If you're doing before or after school, make sure you let me know because, teachers got meetings. So I don't want to tell you yes, but then there's a meeting. So make sure you give me a heads up, okay? Thank you for all your hard work so far, you guys. See you in the next one.